Good day, everyone. Our topic for today is all about light activated silicon controlled switch or LACS. Light activated silicon controlled switch or LACS, like the ECR, is a unilateral 4-layer 3-junction PNPN silicon device with 4 electrodes, namely cathode C, cathode gate GX, anode gate G2, and the anode A. In fact, the ECS is a low power device compared with the ECR. It handles currents in milliamperes rather than amperes. ECS differs from an ECR in the following aspects. It has an additional gate, the anode gate. It is physically smaller than ECR. It has smaller leakage and holding currents than ECR. It needs small triggering signals. It gives more uniform triggering characteristics from sample to sample. Next is operation of silicon controlled switch. The easiest way to understand how it operates is to realize it to be formed of two transistors Q1 and Q2 placed back to back as shown in this figure. In a two-transistor equivalent circuit shown in this figure, it is seen that a negative pulse at the anode gate G2 causes transistor Q1 to switch on. Transistor Q1 here, the PNP, supplies base current to transistor Q2, which is the NPN, and both transistors switch on. Similarly, a positive pulse at the cathode gate G1 can switch the device on. Since only small currents are involved, the ECS may be switched off by an appropriate polarity pulse at one of the gates. At the cathode gate, a negative pulse is required for switching off, while at the anode gate, a positive pulse is needed. Volt-ampere characteristic of ECS. The volt-ampere characteristics of an ECS is similar to that of an ECR and is shown in this figure. With the increase in applied voltage, the current first increases slowly up to point A and then rapidly in the region AB, as shown in this figure. At point B, the product beta 1 and beta 2 exceeds unity and the device is suddenly switched on. In the on state, the current increases enormously and is limited by the external series resistor. ECS also exhibits negative differential resistance in the on region similar to ECR. ECS gets switched on accidentally if the anode voltage gets applied suddenly. This is known as rate effect, which is caused by inter-electrode capacitance between electrodes gate 1 and gate 2, known as transistor capacitance. Advantages and applications of ECS. An advantage of ECS over an ECR is the reduced turn-off time, typically within the range of 1 to 10 microseconds for the ECS and 5 to 30 microseconds for the ECR. Other advantages of the ECS over ECR are increased control and triggering sensitivity and a more predictable firing situation. However, the ECS is limited to low power, current, and voltage ratings. Typically, maximum anode currents range from 100 mA to 300 mA with dissipation rating of 100 to 500 megawatts. A few of the more common areas of application of ECS include a variety of computer circuits such as counters, registers, and timing circuits, voltage sensors, pulse generators, oscillators, etc. And that's all for today's tutorial video. Thank you for watching, guys.